Hello, this video is going to go over the new Ragdoll features that are being put into the Spine Unity runtime. Farron has again created some wonderful artwork for this video demo and actually for the Spine example content as well. You can now find the Raggedy Spine Boy Spine project in the examples Spine Raggedy Spine Boy folder. And there he is. So he's got one basic animation on and the loops. It looks kind of raggedy. It's a nice skid mesh example. The hair floops around a little bit. Good job, Farron. No, seriously, it's awesome. Looks like, right? You guys should have seen the earlier version of this. It was ridiculous. Anyway, to get your character to Ragdoll, there is one question you have to ask first, and that is the Unity physics question. Are you using 2D physics or 3D physics? Each have their pro and cons, but there is a Ragdoll Skeleton 2D or Skeleton Ragdoll 2D and Skeleton Ragdoll. And to add them, you just choose Add Component and choose the one you want. Search for Ragdoll, I guess. And I'm going to mostly be using 2D in this example, just because it's a little easier to talk through. But there are some slight differences that they both work similarly, although the values that you put into this to make it feel right will be different from 2D to 3D, and it's kind of on a case-by-case basis, but I'm not going to cover that in this video. So in the inspector for Skeleton Ragdoll 2D, the first parameter that shows up is starting bone, and this is a regular bone drop-down, and you choose the bone you want to start the ragdoll on. So, you know, in a lot of cases, the root bone is always at world 0, which is not actually what you want as part of your ragdoll. So in most cases, the hip is usually the first bone that you want to start that on. So I'm just going to go through this real quick, and under the parameters, I'm going to choose Apply on Start, and then I'm going to leave everything else the same, and hit the play button and watch what happens. Oh, and the ground has a Collider 2D on it. Hey, it's a ragdoll. Wow, he's pretty stable. Not bad. Okay, so moving on. There's a few parameters in here, like pin start bone, gravity scale that lets us tune up the gravity scale, the same as any box 2D rigid body. There we go. Now he's all broken. You'll notice on start, or rather on apply, underneath the skeleton renderers or skeleton animations transform hierarchy, rather than being broken out into a hierarchy like you would see with skeleton utility, it is actually broken out into individual items that then have the hinge joints attached in the correct location to maintain skeleton hierarchy. The reason for this is that Box 2D and Unity physics do not support things like negative scale, or things like flipx, which is really like a world axis negative scale, and it comes right down to it. So the only way I could get around this was to not rely on the hierarchy, not rely on the actual Unity hierarchy to do this, because as soon as you try to apply negative scale to a collider or a rigid body, it just freaks out, or even worse, a joint. They just do not understand that. So anyway, that's the deal. Moving down the parameter list a little bit. Thickness is, disable IK. This will turn all of the IK constraint mix values down to 0 on apply, but it's up to you to re-enable them if you ever want to get rid of the ragdoll. Thickness is the default width of a bone if it did not already have a collider attached to that, and I'm going to go over that in a little more detail later. Rotation limit, plus minus 20 degrees on each joint. Root mass, this sets the mass of the starting bone's rigid body. So in this case, the hip has a mass of 20 units or 20 kilograms in box 2D language. Mass fall-off factor is a multiplicative factor for the mass of each connected joint. So if the hip is 20 kilograms, and the torso or the abdomen is attached directly to the hip, then the mass of the abdomen will be 40% of the mass of the hip. So you can move down the chain. It just goes all the way down there. If you've ever worked with rigging ragdolls before, the reason for this is generally the root object must be heavier than all of its children, almost put together. Otherwise, the ragdoll simulation tends to become unstable. And you should always tune this value up and down as well as your root mass until you get a stable rig. It's kind of a hit or miss in a lot of ways, but there you go. The collider layer is a simple choice. What layer do you want all of the rigid bodies to be in? Sometimes once the character becomes a ragdoll, you don't want it to collide with the player, but you do want it to collide with the environment, so you create a special layer just for ragdolls that avoids those circumstances. Mix is pretty straightforward. I'm going to throw it back in ragdoll mode. Mix will take the influence of the ragdoll simulation, so the rigid bodies, and then blend it back to the natural animation. So if you're trying to create a transition from the ragdoll state back to the standing state, there's a few helper functions here in the skeleton ragdoll scripts that will help you with that, and I'll show the example of that later. And there's another scene in the examples folder that shows exactly how that works. Okay, so moving on. I'm going to open up Spine, and I think I had one of my other projects open, but I can get back to this pretty quick. Raggedy Spine Boy. Underneath his hierarchy, he's got a bunch of normal stuff, but I've also added the Ragdoll Objects, Ragdoll Attachments underneath their respective slots. And I've drawn these out as bounding box attachments that generally represent the size and shape of the key parts of this character, which in this case are his giant oversized head, and then one in the middle, which is the torso, just to prevent his waist from falling through the floor. I've named them Ragdoll, but you can name them anything that contains the word Ragdoll in it, and the skeleton Ragdoll system will interpret that as a shape that it is meant to be part of the Ragdoll skeleton. So you can see the collider that was generated underneath the head is a polygon collider 2D that represents the shape of the bounding box collider we created in Spine. Misc note for the skeleton Ragdoll 3D version, it does not generate a mesh of this shape. It actually traces the shape and then draws a literal bounding box around it. We do not have a good 3D triangulator for the Spine runtimes yet, but we'll probably make one eventually. Okay, so I'm going to go back now to the thickness property and explain a little bit more about what that means. The thickness value of 0.125, if you did not have a bounding box collider or a bounding box attachment as a child of a specific bone, then the default thickness parameter is used to generate the width of the bone, and then the length of the bone is used to generate the length of the bone. If the bone has 0 length, it uses the thickness value to generate the diameter of the circle joint or sphere joint, or sphere collider rather, where there was a 0 length bone. So that's just kind of how the underpinnings of all this work. Flop over one more time. There we go. So you can see his hair actually has 3 colliders attached to it. And not that you would ever want to not have his hair be floopy, but I'm going to show you what the stop bone names array does. This allows us to create an arbitrary size array and then choose a bone that we want to stop doing the ragdoll simulation on. So in this case, the scalp bone is the first of his hair bones, and I want to allow those to still be controlled by the animation, or simply stop animation if we wanted to by nulling out the animation, so that the rigid bodies aren't generated for his hair. So when I hit play, you'll notice that the hair, while still being controlled by the animation that's currently playing, no longer have rigid bodies generated. This can be really useful if you've got a character with like a sword in his hand or a shield, and you don't want the shield to go flipping out of control or the sword to look weird, or you want the hair to be not floopy for some strange reason. This is a good way to do it. The other use case for stop bone names, or stop bone, is if you have a character that you actually want to still remain standing but only go ragdoll on his arm but stop at his hand and so on. So you can set up a kind of an array of what you want to become part of the ragdoll simulation and what not to become part of the ragdoll simulation. The last parameter here that I haven't gone over yet is the pin start bone. This is pretty straightforward. It takes the thing you mark as the starting bone and it pins it in place. This is pretty cool if you use it in conjunction with the starting bone to do things like have a character react to a punch, where you can say, I only want him to react from the abdomen up. I'm going to still apply on start, and I'm going to choose pin start bone. So this means that his hips are not going to be part of the ragdoll simulation. His abdomen will, but it's going to be pinned in place. So when I hit play, that's all that happens. Oh, looks like we're slowly breaking the physics simulation. So again, this is where we come in and say, take the mass fall off factor and drag it down until the hinge joints are not being overwhelmed by the weight of the rest of the rig. And now we've got something a little more stable. Okay, now we got hit in the face by that. We can even like create a sphere. And, oops. Come on, Unity team. Add some default things for the 2D people. You can create a sphere and you can just kind of push them up or over there or anything like that. So like getting hit by a punch or falling boulders or something like that can now have a little bit of dynamicness added to it. And notice underneath the hierarchy, you do not have hips, you only have abdomen. Okay, I'm gonna go on to the more complicated, but really it's kind of a use case example for how to use ragdolls in conjunction with your project. So under examples, scenes, there is a ragdoll example project, or example scene. And that's got a whole posse of Raggedy Spine Boys. And they are set up with a script called Raggedy Spine Boy that does some pretty cool stuff. I'm going to click play and just show it off for a moment. If you click on one of them, it launches him in the air, lets him bounce around for a while. Now once he stops moving, it detects the stop state and then restores the ragdoll to its standing state, but also updates its position to get back in line with where it's supposed to be. To show that actually happening, I'm going to zoom in here on what's happening in the background. So this Raggedy Spine Boy has a polygon collider and a rigid body. So if I dragged him around, he'd eventually fall, except now he's not a ragdoll. He's a very standard polygon collider that realistically looks kind of like a character controller collider. It's not a big complicated physics thing. It's just meant to represent the general shape of a player for gameplay reasons. So if I click on him, he's going to go through a transition that launches him in the air real quick. There we go. And turns him into a ragdoll. You'll notice a couple of notes, or a couple of gizmos underneath this character. The first one here, which is at the root of the object, is the actual position of the transform that the skeleton was originally generated from. And this other one down here represents the spot where the ragdoll simulation thinks the character should end up if he were to stand up and go back to his original pose right now, from the moment where you applied the ragdoll. What this means is, once this character comes to a rest, it now snaps. Let's find where he lands. Oh, that's not good. Let's get a better one. There we go. Send him flying a couple more times. We'll get a good example. There we go. So it's just a really clean pipeline for launching a Ragdoll. Let's get out of the way. There we go. Really clean pipeline for launching a Ragdoll out and then restoring his position with the original character controller back to where it's supposed to be. So to go over that script really quick, under Raggedy Spine Boy, I'll pop this open, Visual Studio. There's a lot of stuff that's going on in here, but just to glance over it, or the important parts anyway. On launch, which is really on mouse click in this case, I choose the Ragdoll reference, the skeleton Ragdoll reference, and hit apply. And then I get the root rigid body and set its velocity directly, so now it's flying off in some direction. I then start a coroutine called wait until stopped, which is a pretty straightforward thing. Waits for a little while just to make sure we're actually moving already. And then goes through and checks to see if the root rigid body's velocity is dropped below a certain threshold value for a period of time, and then starts calling the restore coroutine up here. This is where a lot of the magic happens. The Ragdoll object has a estimated skeleton position property that you can use to get maybe where the skeleton should be. But as you saw, it actually stuck through the ground before. So in the restore coroutine, I'm going to get the estimated position, the current position of the root rigid body, and I'm going to temporarily store the skeleton point, which is going to become the point where the skeleton begins to reinitialize itself, and set that to initially the estimated position. Next thing I'm going to do is generate a raycast, or a raycast hit, that starts at the rigid body position and heads in the direction of the estimated position, and travels only a distance of the difference between the estimated position and the current root rigid body position, and then only casts against the ground, so it doesn't hit other players or anything like that. And if we hit something within that space, so between those two white gizmos that we saw over here, which one is it? That one. So if we hit something between here, right here, where his rigid body is, and this ground point, then this is going to become the new point. So we can step forward until we get there, and you'll see it snap in an instant in just a moment. There it goes. So now the skeleton origin is right there, and what's going to happen in the code is it's going to set the rigid body to kinematic, the root rigid body to kinematic, so it can't move anymore. And then it's going to use the Ragdoll set skeleton position function, and then you specify the point where you want this to show up. What this does is what I like to call slipping, or I guess in the spine terms, it's actually a shift, in that it moves the root object, or sorry, not the root object, the object that has the skeleton animation on it, to that point, and then it updates all of the children to reflect that change. So rather than moving everything over and then leaving it somewhere, it just kind of slips it back to that position really quick and then updates the spine simulation for you. And now we do a smooth mix, which is another function of Ragdoll, or rather it is a coroutine of Ragdoll. So you call yield return Ragdoll smooth mix, which returns a coroutine, so we're waiting for that coroutine to finish. And I want this changes the mix value from wherever it is currently down to 0 over this duration in seconds. And when we're done with that, we choose ragdoll.remove. That completely wipes out the Ragdoll. It destroys all the rigid bodies, the joints, so on and so forth. But at this point, you won't be seeing any effects from the Ragdoll simulation because we've set the mix down to 0. And as long as there's an animation playing that has keyframes that update the bones, then you're good. And once we're done removing things, we add the original rigid body back in, which is the character collider controller, or whatever you're using for that. And we should be able to see that happen. There's the smooth mix doing its thing. So we're going from the Ragdoll back to the animation state, wherever it may be. Sometimes it might be a good idea to actually make a get up animation and then smoothly blend into it using smooth mix. And pop, we're back to normal. There you go. So that is a pretty deep overview of what's going on with the new skeleton ragdoll scripts. Have fun. See ya.